Welcome to the Jet Maintenance Consulting Corporation 767 Electronic Flight Instrument System or EFIS training course sample. In this sample of JMCC course material, we will cover the EFIS theory of operation, discuss EFIS components and their locations, and discuss system controls and displays. Along the way, we will illustrate system failure indications and cover testing of the electronic flight instrument system. This sample training material was prepared by Jet Maintenance Consulting Corp. It is for demonstration purposes only. All materials contained in this presentation are protected by copyright laws and may not be reproduced, republished, distributed, transmitted, displayed, broadcast, or otherwise exploited in any manner without the express prior written permission of Jet Maintenance Consulting Corp. The Electronic Flight Instrument System, or EFIS, uses information provided by various aircraft systems to generate a visual presentation to the flight crew on the EADI and the EHSI. The information displayed on the EADI and EHSI allow the crew to determine the aircraft attitude and heading. The displays also provide navigation information. The Electronic Flight Instrument System consists of two Electronic Attitude Director Indicators, or EADIs, two Electronic Horizontal Situation Indicators, or EHSIs, three Symbol Generators, or SGs, two Control Panels, or CPs, and an Ambient Light Sensing System. The displays associated with the EFIS are the EADIs and the EHSIs. The displays are color CRTs, or cathode ray tubes, which receive symbol data from the symbol generators. Each set operates independently under normal conditions and has a dedicated control panel, remote light sensor, and symbol generator. The indicators are also capable of displaying text information such as flight parameters and system status. The EFIS displays are located on the forward instrument panels. The EADI displays attitude information along with navigational data and flight guidance. The navigational data consists of a fast-slow pointer, localizer and glide slope data, ground speed, and radio altimeter information. Flight director steering bars are also displayed along with flight mode enunciators, or FMAs. The FMAs display the various modes of operation of the autothrottle system and the autopilot flight director system. The colors used on the displays generally have the following meanings. Green indicates engaged flight mode enunciations or dynamic conditions. White indicates present status situation, scales, and flight mode enunciations. Magenta indicates command information, pointers, symbols, and fly to conditions. Cyan or light blue indicates non-active background information such as the sky. Yellow indicates cautionary information, faults, flags, etc. Red indicates a warning, and black indicates blank areas. The EHSI displays heading information along with navigational data. The EHSI can be displayed in either full mode, a 360-degree compass rose, or the expanded mode, which is a sectored compass display. In the expanded mode, weather radar and terrain information can also be displayed. In the plan mode, the flight plan is displayed in a north-up format and does not relate to the compass information shown at the top of the screen. The upper compass portion of the display conveys real-time flight conditions. The symbol generators, or SGs, are responsible for creating the displays on the EADI and the EHSIs. The left symbol generator supplies the captain's displays, while the right SG supplies the FO's displays in normal operation. A center symbol generator can be utilized by either or both crew members as a backup. All SGs are equipped with a test switch and a reset switch used to reset an internal fault memory. They can also be tested from the cockpit. The symbol generators are located on the E1 rack on shelves 2, 4, and 5 in the main equipment center. There are two EFIS control panels. The upper portion of the panel controls the EADI, while the lower portion of the panel controls the EHSI. The EFIS control panels are located on either side of the aisle stand. The EADI controls and their functions are as follows. The EADI display brightness control is a rotary knob used for adjusting the EADI brightness. The decision height set control is a 2-speed 10-turn rotary switch used to select the decision height. If the control is turned slowly, the display will advance 1 foot per click at 24 feet per revolution. If the control is turned quickly, the display will advance 4 feet per click at 96 feet per revolution. The selected decision height readout is a 3-digit LCD display representing the selected decision height in feet. The decision height reset switch is a push switch used to manually reset the decision height alert. The EHSI controls and their functions are as follows. The range switch is a 6-position rotary switch used to select display range. It also controls the range processing in the weather radar receiver transmitter. The switch selects 10, 20, 40, 80, 160, or 320 nautical mile display range. There is a TFC or traffic switch on top of the range switch, which you can push to get TCAS indications to show on the EFIS displays. The EHSI and weather brightness controls are 2 concentric rotary controls. The outer control is for the overall EHSI brightness. The inner control is for the weather radar or EGPWS brightness. The weather radar on-off switch is used to turn on the weather or EGPWS terrain display on the EHSI. The EHSI mode switch is a 6-position rotary switch. It is used to select the map, plan, expanded VOR, expanded ILS, full VOR, or full ILS display modes for the EHSI. The EHSI map mode display switches are a set of 5 push-on, push-off switches. The left switch is in op. They illuminate in the on position and call up useful display data in the map mode. When in the on position, the following data will be included in the map display. The NavAid switch displays all VOR, VORTAC, and NavAids with identifiers in the displayed range. The airport switch displays all airports and identifiers in the displayed range. The route data switch displays altitude and estimated time of arrival next to all flight path waypoints. The waypoint switch displays all waypoints with identifiers not on the flight plan and within display range. During pre-flight, the crew will set the intensity of the EFIS and EFIS displays to suit their personal liking. Once set initially, an automatic intensity system will maintain this same relative intensity as ambient light conditions in the cockpit change. The left and right remote light sensors are located on the glare shield. The remote light sensors detect the amount of ambient light coming through the windshield and are used for automatic intensity control of the display units. The light passes through a lens and is sensed by a photodiode light sensor. The diode allows current to pass through it, which corresponds to the amount of detected light. The voltage is sent to the display units to automatically adjust their brightness. Additionally, each display unit has a local light sensor on its face. The left EFIS system automatically controls the intensity of the EFIS display units. An instrument source select panel is located on either side of the forward instrument panels. The alternate EFI switch on the panel provides a means of selecting the center symbol generator in the event of a failure. Note, if the center symbol generator is selected, TCAS indications will not be provided on the selected side. If a symbol generator fails, the center symbol generator may be selected to the failed side, or in the event of a dual symbol generator failure, to both sides simultaneously. In this instance, the left symbol generator has failed. Pressing the left alternate EFI switch selects the center symbol generator to the left side. In this example, the right symbol generator has failed. Pressing the right alternate EFI switch selects the center symbol generator to the right system. Note that the right inertial reference system is also selected to the center symbol generator. Here is a dual symbol generator failure. Selecting both alternate EFI switches allows the center symbol generator to provide data to all 4 displays. Notice that the left or captain's EFIS control panel controls all the display selections. Testing of the EFIS system can be accomplished from the cockpit or from the test switch on the symbol generators. In the cockpit, pushing the system test switch on the P5 overhead panel will simultaneously test all of the EFIS components. To see the results from the center symbol generator, one of the EFI switches on one of the instrument source select panels must be pressed. Now let's look at EFIS test indications. With any mode but plan selected, the display on the EADI will look similar to this during the test. The test results appear in the lower left-hand corner of the EADI. If the test is successful, a Test OK message will be displayed. If the test has failed, the Test Fail message will be displayed along with the cause of the failure. CP for control panel, DU for display unit, and SG for symbol generator. The symbol generator program pin configuration is displayed on the right side of the EADI. This is the test display if the plan mode has been selected. Again, test results appear in the lower left-hand corner. Similarly, test results appear in the lower left-hand corner of the EHSI. If the test is successful, a Test OK message will be displayed. If the test has failed, the Test Fail message will be displayed along with the cause of the failure. CP for control panel, DU for display unit, and SG for symbol generator. The hardware and software version numbers are displayed on the left side of the display. Here is the EHSI test display with the plan mode selected. If one of the modes that can display whether radar returns has been selected, an EFIS radar display test can be performed. This is not a radar system test, but rather a test of the EFIS ability to display radar information. Since this test requires the off-on switches for the radar system to be turned on, make certain the radar transmitter is disabled when doing this test. To remove and replace a display unit, loosen the 2 screws in the handle, and a hinged mounting assembly folds down to become a carrying handle. As the handle is pulled down, an over-center mechanism unlocks the display unit from its rack. Be sure to keep pressure on the handle while removing and installing the screws. The handle is spring-loaded and will cause the screw threads to strip unless the spring pressure is overcome. One of the primary causes of a display unit overheating is blocked cooling screens on the rear of the unit. If the display units overheat, they will blank out. The cooling screens are to be cleaned on each A-check. When an EADI is removed for cleaning, the aircraft lower landing minimum status may be affected. Faults are enunciated for system failures, mode failures, and no computed data conditions. A system failure is indicated by a yellow box with the system identification inside of it. A mode failure is indicated by a yellow line drawn through the mode enunciation. No computed data means that the system on the aircraft is okay, but for some external reason the data cannot be displayed. No computed data is indicated by green dashes. Here are the failure displays with one of the EHSI expanded modes selected. Only system failures or no computed data will be displayed on the EHSI. This graphic shows failure indications in the EHSI full mode. Just like the expanded mode, only system failures or no computed data will be displayed in the EHSI. Congratulations! You have completed the 767 Electronic Flight Instrument System Sample Training Module. Please visit our website at www.jmcnow.com and explore our aircraft maintenance training, engineering, and technical publication services.